Are people still looking at these? Okay. And then I'm going to show you like a little demo on a website and have you like go back and look at your answers and see if you still agree with your own answers. All right, let me show you this. You might not be done, but that's okay. Like, let me show you what I want to show you here, and then you can go back and look at this and kind of recheck your answers and see if you still think the same thing after I go through this. So this is going to automatically generate confidence intervals for me. I'm going to put, you can choose like the population proportion. I don't know if you can see that thin little red lines moving around. Green line, yeah, screw you guys, you colorblind, you color people. I'm colorblind, so I can't tell. I probably shouldn't say colored people. They suck, they don't work. I've tried 2 different ones. They're like $500, but it has money back guarantee. And it's just like sunglasses. They don't do anything. Anyway. Yeah, I can see that. That's kind of what. Are you colorblind? Really? Mine is not. So I don't know if you've ever seen a stop traffic light, but they put like the red's always on top, and then the yellow, and then the green. Okay, so I want to go through like here's an 80% confidence interval and a sample size of let's say 30. So that'll do one sample. So if you remember, our true population proportion is 0.5, but any one sample might suck. It might be good. It's just like one sample. There's nothing special about it. So this first sample that was generated here, the point estimate was 0.333, and when you do the margin of error, remember we talked about if it's an 80% confidence interval, 80% of these little samples that create their own confidence level interval will hit this line. So if I just keep going, so if I did that over and over and over again for eternity, 80% of them would capture the actual value. So like this did not capture the actual value because the actual value is 0.5. This did, this did, this did, this did not. But like what 2 and 3 on the warm-up are asking is what happens if I change the confidence level or what happens if I change the sample size. So if I change we talked about this last week too, like if you have to be 100% confident that you are guessing my weight between this and this, or you die, you're going to say like 0 to a million, 100% confident you want like the widest possible thing. So if I change this confidence level to 90, you can see like they literally just expand, they just get bigger. So as the confidence level goes up, what is happening to your width? It's increasing, and your margin of error is increasing. Sample size. Let's hold the confidence level at 90 and look at sample size. So as the sample size gets bigger, remember we did talk about, like, as the sample size gets bigger, your normal curve goes from this to like this, like it gets skinnier and taller. So let's do like sample size of 30. Let's change it to a sample size of, I think this will like erase it. So like, kind of remember how big these are. Now let's make it a sample size of 150. Let's see how much smaller they got. Sample size of 500. Now they're really small. Because now you have so much information. You have like 500 data points. Whereas if I only have 10 data points, like I'm guessing a lot, and you'll get this really wide range. Other way to think about it is like, it's just the math. The sample size is down here on the bottom of a fraction. So like if I have like 2 divided by 4, what's that? 0.5. If I have 2 divided by 10, what's that? 0.2. If I have 2 divided by 100, what's that? 0.02. So as the number on the bottom gets bigger, what happens to my answer? It gets smaller. So if I put a bigger number on the bottom, I take a bigger sample, that's going to make your standard deviation smaller. And if your standard deviation is smaller, then you are adding or subtracting a smaller amount, and you just don't go as far. So I'll give you a second to like rerun through those, see if you want to change anything, and then I'll talk about it. Maybe you don't want to change anything. Maybe you're good. Maybe you don't know what I'm talking about. I don't know. Take a second though. Changes? Okay, so C star. Remember there are 2 ways. I'm going to do part A. You can look at it 2 ways. You can say, okay, there's 90% in the middle, and I need to find that z-score or that z-score, whichever way you want to look at it. Well, if there's 90% in the middle, there's 10% left over. So that must be like 0.05 or 5% and 0.05. So I could do inverse norm of 0.05 to find that z-score. That one will come out negative. You just ignore the negative though. Or you can do inverse norm of 0.95 because 95% is below that. Or we talked about there's like the formula you can use. Some people are like, I don't want to think through that every time. I know it's just going to be inverse norm of 1 point, whatever the confidence level is. In this case, 1.90 divided by 2, which you notice, like if you do 1.90 divided by 2, it's 0.95. So like this is the same thing. It's just shortcutting it there instead of having to think through it. And that is 1.64. So same thing for part B. I can draw this out, or I can just kind of jump to this. This will be inverse norm of 1.95 divided by 2. So this is 1.96. Or that's 1.9599. Question on 1 then? Alright, 2. As the confidence increases, what happens to each of the following? So Z star, think about this 2 ways too. So there's usually like a conceptual understanding or like a math reason. If you need to be more confident or you die, what are you going to do with the size of your interval? You're going to make it enormous, right? So that's one way you can look at it. As confidence increases, Z star is going to get bigger. And Z star has to get bigger because if I want to make my interval bigger, I want to add and subtract a bigger number. So if I multiply by a bigger number, this part gets bigger, and then I'm adding or subtracting a bigger number, so I go further in each direction. Or you can just do it. Like if you just look at the math, as the confidence level went up, because I went from 90 to 95, what happened to Z star? It also went up. If I increase increase my confidence level, does that have any impact on your standard deviation? This is the standard deviation. Does it have anything about the confidence level in that formula? It's just whatever the proportion is in the sample size. So the confidence level does not affect the standard deviation, so no change. Margin of error. As the required confidence increases, that number is going to get bigger. If that number gets bigger, your margin of error, since it's this times this, will also get bigger. So this is increasing. Okay, for 2. For 3, as my n increases, what happens to z star? Well, z star has to do with the confidence percentage. Does my n have anything to do with z star? It does not. So this is no change. Z star is inverse norm, and it has to do with the confidence interval, and that's it. The confidence level, and that's it. N has nothing to do with it. As my n increases, what happens to my standard deviation? It's a hugely important concept. I'll ask about it all the time. So I tried to just show you on the graphic thing, as n got bigger, our little things got smaller. Again, the reason is I'm dividing by a bigger number. So if I'm dividing by a bigger number, the answer gets smaller and smaller. So this goes down. And then margin of error is when I multiply these two together. So if this thing gets smaller, I'm going to multiply them. Doesn't the whole thing get smaller also? So this is also done. And just conceptually, like if n goes up, you have more information. You're going to be better at guessing whatever you're trying to guess. So you can kind of zoom in on it a little bit more. That's why these both go down. 3, okay? Then 4, this is like definition-ish kind of stuff. So point estimate is whatever's right in the middle. So that'd be 0.7. The width is from one end to the other. So that's 0.2. Margin of error is how far it is from the middle to either side. So that's 0.1, and then this would be 0.7 plus or minus 0.1. Questions there? Okay. I want to do another example, and I want to do like a template where it's just like here's what you like, here's the guide to do no matter what the problem is, just like in general. Do you guys have a preference which we do first? Template, and then you can use that to go through like the problem. Let's try that. Okay. So hopefully you have a blank page left in your notes somewhere. This is the thing I told you to save it for. One blank page. Okay, we are going to do a confidence interval for a sample proportion. In your calculator, this is called a one prop z-int. And we will use calculator just now. the first part's, you might say state, you might say intro, but we have to like declare what's going on. So I'm going to say, you don't ever have to write the words state, conclusion, intro, whatever. That's just kind of help you organize. If you want to write state or intro here, that's cool. You don't have to. But I'm going to say P equals the true population proportion of, and then you're going to put the context of the problem. And then you're going to say what we're trying to do. It's like your thesis statement. We want to estimate P at a whatever percent confidence level. So it's like your introductory paragraph, your thesis. Like here's what we're going to do. I have this sample data. I don't really. That's not what's important to me. What's important to me is trying to use the sample data to guess the population information. And that's what we're going with. And then it'd be like conditions. You write the steps there. And this is shape, center, and spread. We have a condition for each. So the shape is going to be approximately normal as long as what? Good. And P is greater than or equal to 10, and then Q is greater than or equal to 10. The center is going to be P as long as there was randomness. SRS, or it says randomly assigned, whatever. Okay. And then the spread, so your standard deviation is going to be the square root of PQ over N as long as what? Not greater than 30. Yeah. That's for means. For proportions, we want to offset. As long as little n is less or equal to 10% of your population. So then we get to, you don't really have to write this, but the idea is then we get to this. And I know we are approximately normal. I know the mean is P, and the standard deviation is root PQ over N. Alright, and then I do my math. So I'm going to write the formula in words, in symbols, and then in numbers. So in words, it's what's up there. So point estimate plus or minus. And you can put, so these are the same. You can either put margin of error or you can put critical value times standard deviation. So it kind of depends what you want to help remember better. Some people have trouble remembering that the margin of error and these two multiplied are the same. So if that's true for you, you might want to write that one. Some people have trouble remembering like what exactly to do, so you might want to write that one. It's up to you. You write both. They mean the same thing. You kind of choose which you prefer. I'm going to do critical value times standard deviation. And then in symbols, my point estimate is P hat. critical value is my z star. My standard deviation is the square root of p. And then you put in numbers, which I can't really do because we're just doing like a general template. But you put something there, you put something there, put something there, time. And the only one you might need, I think, the one you might need like remembering is this z star. And that's what we just did in the warm-up. So that's your inverse norm, 1 point. If I put like 1 point xx divided by 2, does that make sense? It's like a 95%. You put 95 where the xx is. Yeah. Yeah, it took me a second to catch up because we said clarify it. It occurred to me that was your name, and I traveled down that thought process for a minute. Yes, we're still at 1. Yeah. Like I was trying to think if anyone else could ask me a question with their name. Alright, I'm sorry. And then you are going to like actually find the answer. So it'll just be like blank to blank. And for today, we're actually like calculating that out. Like we'll figure out this calculation here, and we will add and subtract it to this number. But tomorrow, I'm going to show you your calculator does it for you, which is pretty nice. I just want you to practice this so you know what you're doing. You know what the calculator's doing, but tomorrow it'll be a little shorter. And then conclusion. So you're going to say we are whatever percent confident. So whatever the problem was saying. That P, and remember P is context. It doesn't really seem like it because you're just writing a P. But P was defined as the true population proportion of whatever. So that P kind of has context within it. So we are blank percent confident that P is between whatever, and you just take those two numbers. So that's like your general, if you follow through those steps, you should be good. Questions on that one? Anything on there? Alright, so I want you to try one. So use the template, and I'll put up a problem, and then give you time to do it, and then I will do it as well, and we'll check it and make sure we're on the same page. There it is. No, let's do it. No, let's do this. Let's do an actual sample. Raise your hand if you prefer the 6-hour schedule to the 7-hour schedule. Yeah, prefer like this year's style to last year's. Raise your hand if you prefer last year's. Raise your hand if you don't care either way. Alright, we're gonna do this. 14 out of 30. This is not here. 14 out of 30 randomly sampled students. You guys are a random sample of students. Pretend you're a random sample. When you do so I titled the template, right? That title is part of the requirement for what gets graded on that problem. So I titled it either confidence interval for sample proportion or one prop z interval. Like I put those both at the top of the thing. You have to put one of those. You have to title it because we're gonna have like 12 of these procedures. So you do one side. I have no idea. Has it been a while? The Stanley with all the lead.
Oh, you heard about that?
Yeah.
Oh, that
Class, if we're still on like the notes one, I think we're doing like section one like all week, and then section two probably all next week. And so I said that. So there's gonna be initially 8 of these processes. So we do like these first 2 we spend a ton of time on, and then the next ones go really quickly because we've got like the foundations kind of established. So we are gonna spend like a while on this section. That's what we're trying to build a solid base for going forward. I will not tell you, and you don't get it sure, but we will practice. What? No, P is whatever 14 divided by 30. Let me show you a faster way on this type to do the conditions. So if you wanted to do this, P hat is like 14 over 30, right? For P. P and P hat are the same because we don't know P. But and then you got to do N times P, right? Is greater than equal to 10. Well, there's 30, and then P is 14 over 30. So isn't that just going to be 14? So another way to get to this is what this is really the like greater than or equal to 10 thing is really saying is we need at least 10 expected successes, and we need at least 10 successes and 10 failures. How many successes do we have? 14. How many failures? 16. So you can just kind of you can shortcut that and say 14 failures, 14 successes, 16 failures. Those are both greater than equal to 10. This works too, but this is a little faster. When you, because it comes out to 0.466666, right? If you do like 0.4 and the person next to you does 0.46, those are going to be very different answers because of all the math we're going through. Use as many decimals as you can like mentally handle. Like I put 0.46666. It'll just make it a little more accurate. But then once the calculator gets involved and I show you how to do it on there, which I might even do today, we don't really need to worry about it. I'm going to start putting my answer up, so if you don't have that written down, do that soon. Is everybody okay with what's up here? I can take this down. Is everybody done with the math part yet? I got 0.31685 for my first number. You have to write on everything I wrote in the template. Like I've narrowed that down as much as I possibly can. So you guys about this part? They want to see it, and I don't mind that they make you do it because it kind of keeps it in your brain. Because that's a multiple choice thing that comes up a lot.
You say sure instead of confident.
No. So I'll talk through this in a second. Like just pointing out things along the way. But if you want to look at it while you're going, check stuff. There it is. So, just pointing out things that people miss a lot. Don't forget a title. That is required. I don't agree with it. I think it's annoying. Like you do. These are usually 4 points on the AP test. And if you don't put the title, they take 1 off. Like you did all that crap and you just got like a 75% if you did it all right. So it's annoying. I agree. It's some BS, but it's the game we're playing. So P is the true population proportion. That's what we're trying to find. We want to estimate it. This is that 14 successes, 16 failures. They're both greater than 10 thing I was talking about. You could also run through the like NP and NQ and show those are both bigger than 10. Question or stretch? This is my center because that's 14 out of 30. You can also put 14 over 30. This is my spread, and I know that because I'm less than 10% of all students. Then I'm writing the formula out in words. I'm putting the symbols in. So what you're telling the person grading it is, I know the point estimate is p hat. I know the critical value is z star. I know the standard deviation is this. And then I wrote out those values. I didn't plug them in here because I had already plugged them in up here. You don't need both, but just in one of those spots, like put in the numbers. So I just put 0.09 because I had already like done it up there. And then I just cheated. I'm assuming you guys, I don't know if you guys figured out how to cheat with the calculator or you did it by hand, but those are the numbers you should get. And then concluded, we are 90% confident that P is between whatever and whatever. Any questions on this that I can address? Let's look at, yeah. First number in the parentheses. Right here. So it's going to be this 0.46666 minus 1.645 times on that. And then the other one's plus. Yeah. Z star is the, so I did inverse norm 1.90 divided by 2 because there's a 90% confidence interval. You put 9 on it. What? Oh, yeah, so you should put 0 and 1. That's like the default. Alright, I want to look at the conclusion for a minute. Let's say that Mr. Shin says 80% of students prefer the 6-period day to the 7-period. He says 80%. I take my random sample. I'm like, I'm 90% sure that the true answer of students that prefer a 6-period day is somewhere in between these. Would I call him a liar? Would I reject his claim? I would, because 80% is not it. Like, I'm pretty sure the true answer is in between there, and the number you gave me is not. So I think you're kind of full of it. And that's what we get into, like, the next couple months. Like, someone's going to make a claim, and we're going to run some math tests and be like, oh, that's a bunch of crap, or like, okay, yeah, maybe you're right. What if he said 50% of students prefer the 6-period day? Would I call him a liar at that point? I wouldn't, because 50% is in there. Like, okay, that's reasonable. If he told me 31, or 32, 34, 60, 50, anything in there, I'm like, okay, sure. Something on the outside, I would call him a liar. Other questions on? Alright, let me show you how to do it in your calculator. It's a heck of a lot easier in Python. So go to stat, and then tests. You want to go down to there's a 1 prop Z test. I don't want the test. That's what the next unit is. I want the 1 prop Z interval. It's A. Stat tests A. And then what you put there is the number of successes for X and the total for N. And then your confidence level. It will not take decimals. These need to be whole numbers. Like how many successes were there, how many total people were there. If you try to divide 14 divided by 30 and put that in one of those spots, it's going to blow up and get mad at you. It won't do what you want. It'll say here or whatever. These have to be, this is just like the proportion of successes, 14 out of 30. And then if you go ahead and calculate, They'll give you the numbers that we just gave out. There's your B hat. There's your one what? They give you the 0.31685. You scroll over. You didn't do anything. I just showed you. Stat. No. You did it. I don't know if we did it or not. What does that get me?
Oh, I hit enter twice.
Anybody else have an issue like with the content? How do what? You're getting one of
I
those.
pressed it twice. I pressed enter twice.
So that's you like trying to calculate.
That's just what she said.
That's what we're looking for.
No, that's what.
Oh, it does. That's why. Okay, so it's that.
Well, that's an enter four.
That's how it is.
Oh, I see.
Any other calculating issues? Alright, let's do this. Island High School claims 80% of their students go to college. We take a random sample of 50 graduates, and we find out that 32 of them went to college. So here's the thing, like, they claim 40, right? They claim 40 out of 50. Hold on. Still trying to explain something. They're claiming 80%. So 80% would be 40 out of 50. If I take a random sample of 50 and I get 39 instead of 40, is that enough for me to be like, yeah, he's full of crap? That's a lot. I'm like one away. Like that could just be because of sampling variance, sampling variation, either way you want to say that. What about if it's 38? Think he's still okay? 37? 30, like, where's the cutoff, right? Like, that's, we need some mathematical way to say, like, okay, at this point you've gone too far, and now I think you're lying. And that's what these processes do for us. So he's claiming 80%. Is 32 over 50, like, far enough away from 80% that we're going to call a liar? Or not. So you don't do the whole, like, process. Just put that in your calculator, get your interval, and then answer my question. Like, would you call him a liar or not? Get the interval and decide if he's lying or not. Based on our sample, when he says 80% going to college. Don't ruin it for everybody. Wait, do you actually know it or you just... I didn't do it. So stat tests, 1 prop C interval, 32 out of 50. Oh, I didn't tell you what confidence level. 80 was his claim. Okay, that's fine. I don't care if it's 80% confidence. I just want you to understand that the confidence level and like his claim are two separate things. They might be the same number, but they're two separate things. Okay, let's put 0.8 then. Alright, so we're gonna call the liar. What could we do? What number? I would call the liar as well because 80% is not in there. What could I change? Or he could come down and say, well, hold on. You didn't do what I would have done. If you had changed this, 80% would have been included. What could you change? Change the confidence level to 0.5. What did we have? What were the numbers a second ago? No, like it was like 0.7 and okay. If we're gonna include 0.8, do we want that to get bigger or smaller? Bigger. If you want something bigger, less confident? If you have to be 100% confident in something, how wide are you going to make it? As wide as you can. So if you need to be more confident, what do? Bigger confidence level. So he could come down and say, well, that's correct. Do a 90%. See if you're still going to call me a liar. Maybe we do, I don't know. So we still do. I'm just trying to reinforce that when you increase the confidence level, it makes it bigger. So maybe he'd be like, all right, well, try 0.99. I don't know if that's going to get there either. But. So if we had to be 99% confident, like if we have to be damn near certain before we call him a liar, now we can't. So as you increase the confidence level, it's going to build that range bigger and bigger. Questions for me on any of the? We did a lot today. Okay. Don't worry about the homework or anything yet. I got plenty of time for you to do it.